In this video, we're going to look at what happens when you don't just shoot an object horizontally, but you shoot it at some angle. So this is angled projectile motion. Now this is where that trig part of your reference table comes in handy. Now before you start using your calculator, take a second, pause this video, and check that your sine 30 equals 0.5. So you type in sine and then 30 is supposed to equal 0.5. If it doesn't equal 0.5, you're in radians, and you must go into mode, and there'll be a choice between radians or degrees. You're going to want to choose degrees. In physics, we're always in degrees. Now, if you end up going back into calc or pre-calc, you're going to have to change it back. We do deal in different angles, or different units of angles. Now, quick trig review. There are two parts of your reference table that's awesome. This part, and then this part. This is in the equations part of your reference table. And basically it's telling you AX and AY equals your hypotenuse times sine. So if I label my sides of my triangle, I'm going to label it A because this is my total velocity. So let's say I'm kicking a soccer ball with a velocity, initial velocity A at such an angle. Angle is represented by theta. Okay, so if I'm looking for my initial vertical velocity, then I would say, okay, I want A sub y. So I want my vertical velocity, the vertical part of A. Alright, well I know my angle, so I know theta, I know A, and I know AY, which is the same thing as saying I know theta, I know C, and I know A. Okay, it's just the parts of the triangle, depending on what you label them. So if you know theta, C, and A, you go up here and you say, okay, this one has B, so no. This one has B, so no. And this one has B, so no. This one. So sine theta equals A, which is AY, over C, which is A. Simplify it, you get A times sine of theta equals AY, which is this down here. So you can use the triangle that you see in the trig part, or you can use this in the equations part. Both of them work. Now let's look at an example. Raven's kicker kicks the ball with an initial vertical velocity of 4.1 meters per second and an angle of 30 degrees from the ground. What is the initial vertical and horizontal velocity of the ball? Alright, well, I have this triangle here. I know theta equals 30. I know I kick it with a total initial velocity of 4. So C equals 4. What is the initial vertical velocity and horizontal? So I want to know A and I want to know B. Well, if we solve for A first, we know theta and C, and we're looking for A. So we find our equation with theta, C, and A. So sine theta, sine of 30, equals A, which we're solving for, over 4. So we get sine of 30, plug it into your calculator, you get sine of 30 equals 0.5. So 0.5 equals A over 4. A equals 2. That is your vertical velocity. Right? That's the vertical part of the triangle. The horizontal part of the triangle would be B. Now we know AC and theta, and we're looking for B. So we know everything, so we can use any of the equations with B. I'm going to use Pythagorean theorem. I like Pythagorean theorem. I think it's easy. So A squared plus B squared equals C squared. So 2 squared plus B squared equals 4 squared. So 4 plus B squared equals 16. So B equals the square root of 12. Which is 3.464. So 2 meters per second vertically, 3.464 meters per second horizontally. Now if you take, let's say, this equation, you could do it that way too. AY, so my vertical velocity, equals my total velocity, 4 times sine of 30, which equals 4 times 0.5, which equals 2. So either way, they both work. Now when we're dealing with angled projectile motion, it's like smushing two things together, two-directional vertical and horizontal projectile, because now there are 3 directions. It's traveling up, it's traveling across, and it's traveling down. So 3 directions. Each direction is independent. Okay, so if we have 3 directions, each independent, we're going to have 3 sets of variables. 3 VI, VF, ADTs. Now, the only thing that links them, once again, is time. But in this case, the time horizontal is the total time vertical. So the time up plus the time down equals the time across. Now the same things from before still come into effect. If you're going up and down, at this point your vertical velocity is 0. So final on your way up, initial on your way down. Horizontal, acceleration is still 0. Only thing acting on it is gravity. Vertical, negative 9.81. Your distance down is negative, your displacement is negative on the way down. And total time is time up plus time down. That one's kind of new. So this is from the vertical two-directional. This is from horizontal projectile. Okay? And that's kind of new, though we did kind of cover that in certain places. Now let's take a look. Let's continue that problem. We have that Raven's kicker. That Raven's kicker kicked at an angle. So we found the initial vertical and the initial horizontal. Now we plug those in to our variables. Okay, those numbers we found, we say, okay, initially it's traveling up at 2 meters per second and across at 3.464 meters per second. The question is, what is the range of the kick? So this is our question mark. Now if we fill in what we know, horizontally we know our acceleration is 0. Vertically we know our acceleration is negative 9.81. The other thing we can usually fill in is something to do with velocity. Well, on the way up, our final velocity is 0. On our way down, our initial velocity is 0. Alright, we go back to things we need to remember. Check, 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 check. Our D is supposed to be negative on the way down. So this will be some negative number. Okay. Now this is where things get tricky. We're looking for D here. In order to find D here, we need to find T, because we have VI, we have A, VF is going to be the same as VI, so it's not going to be useful. So we need to find T. T equals time up plus time down. Now it left from the ground and returned. So in this case, okay, not always true, but in this case, time up is going to equal time down. Right? Because it left from the same height it returned to. So vertically, time up equals time down. So all we need to do is find one of those times. Well, let's see, which one can we do? We only know 2 things in down, but we know 3 things in up. So we can find our up time. We're going to pick the equation without D. So VF equals VI plus AT. VF is 0. VI is 2 plus negative 9.81 times T. And we get 0.2 is our time. So if we know our time up is 0.2, in this case we know our time down is 0.2. Now if that wasn't the case, if let's say it landed on a cliff that was 3 meters above it or something, then you would have to find D and use that D to find that D. But luckily, we don't have to do that. Time up equals time down. So our total time up plus time down, is going to be 0.2 plus 0.2. So that's going to equal 0.4. So now we know T, A, and VI. We can find D by using the equation without VF. So D equals VIT plus 1/2 AT squared. D equals VI, 3.464 times T, which is 0.4, plus 1/2 AT squared. Now A is 0, which means this whole thing is 0. So D is just 0.4 times 3.464. And we get 1.3856 meters. Okay? So all we got to do is keep into account that we got up and down. If it goes at an angle, it's initially traveling up and across. So we have an extra factor in there. So rather than having that initial horizontal velocity of 0, or initial vertical velocity of 0, we now have some value. Alright, that's the end of the lesson. Good luck. Don't forget to complete your homework.